Hi all, my name is G. Pushmallu, working as an assistant professor in the Department of Electronics and Communication Engineering at St. Martin Engineering College. Today, my video lecture is IoT communication protocols, right? So why IoT communication protocols is very important in the IoT. For example, what is IoT? IoT is the Internet of Things of physical object which are embedded with electronics, sensors, and which are connected with some internet, right? So IoT means we require as a some things and we require as a some internet, right? For example, internet is there. So what we will do with the help of internet? So we are going to browse something and we are going to get some kind of information, right? But with the help of Internet of Things, so here we are going to internet plus things, it is going to become as a Internet of Things, right? So what are the things generally we are going to use in the embedded system? Generally in majorly, we are going to use as a sensors and actuators, right? So why these IoT communication protocols is a major role is in the IoT system. For example, if you want to design one IoT system product, so what are the things we require? The first thing we require as a hardware devices. So what are the hardware devices we require? For example, we require as a sensors, actuators, some kind of boards, Arduino, Raspberry Pi. These are the hardware devices is required. Then we require as a some software for writing the programs for the particular devices. We require as a software. On the top of the software, we require as a some communication protocols. These all are only communication protocol. Next, on the top of the communication protocol, we require as a cloud. So what is the use of cloud here? For storage of the some information, whatever the IoT devices is going to generate, the data we are going to store in the cloud. On the top of the cloud, we require as a some user interface. For example, you want to get some kind of temperature value in your mobile phone. In your mobile phone, we are going to install one kind of application. Based on that, so whatever the values is going to generate, that values we are going to get somewhere but we are going to get without human interaction only. It is going to happen everything. That's why, so we require majorly for the development of particular IoT device, we require as a hardware devices, and we require as a software, and we require as a communication protocols, and we require as a cloud for storage, and we require as a application, it is a user interface, right? Today I am going to discuss about IoT communication protocols. So what are the IoT communication protocols here? It is in the generally, so OSI reference model, it consisting of 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Out of 7 layers, so here in the IoT communication layer protocol, it is going to consisting of 4 layers we are going to take. In the first layer, it is the application layer. In the application layer, we are going to discuss what? The first protocol is HTTP. It is a hypertext transfer protocol. The next one is COAP, constrained application protocol, and third one is WebSocket. Generally is used for the full duplex communication. Next one is the MQTT, message queuing telemetry transport. It is a publish subscriber model. Next we are going to use as a XMPP, extensible message presence protocol, and DDS, data distribution service, and next one is a AMQP, advanced message queuing protocol, right? These are all the some protocols it is going to included inside the application layer, right? We are going to discuss one by one. The first one is what? Hypertext transfer protocol. It is a worldwide web application. For browsing, we are going to use what? HTTP. It is a client server architecture, right? So how it is going to work? HTTP, hypertext transfer protocol, client server architecture. Here client will send request to the server will respond to the client here, right? Client is going to send some request to the server is going to respond to the client. So here maybe respond whenever we are going to send from client to server will may respond and may not respond, right? So for example, how it is going to work, HTTP client, right? So here server, right? From client to server, we are sending some request, right? So here the server will respond, right? So for sending between client and server, here we are going to use some commands, right? We are going to use as some get command, put command, delete, update. Some commands we are going to use whenever we are going to communicate with the client and server. For example, it is a get command we are going to use. So the client is going to send request to the server will respond to the client. So here some status codes we are going to get, right? For example, whenever we are going to sending the connection request from client to server, for example, if you are going to get us a 200 to 299, it is what? Status code. Means it is going to establish the connection successfully. For example, whenever we are going to send client to server, so here we are sending some request with the help of some get command and we are going to get some response. That status code is going to get. So if we are going to get as a status code 200 to 299, we are going to get as the connection established successfully. In some situation, we are going to get the status code is 300 to 399. That it is going to indicate that redirection. So it is redirection. So right, it is connection established successfully. For example, if you are going to get as a 400 to 499, then it is a client error. For example, if you are going to get 500 to 599, so it is a server error. If you are going to get 404, it is a page not found. These kind of some status codes we are going to get whenever we are going to work with the client and server, right? So whenever we are going to send some request to the server will respond. The response may be based on this status code, right? If you want to see the status code, so here we have to use backend. If you are going to get this all the things, so what is the status, and we are going to get as what is the source IP address and destination IP address, all those things we are going to get. In the next network layer we are going to discuss regarding, so network layer like what is internet protocol, right? What is the internet protocol version 4, all those things we are going to discuss, right? So it is what? Client server architecture. The port number of HTTP is 80. So here, for example, if you are going to develop one website, HTTP website, right? So on your name, in that case, if you are going to open this port number, then only we are going to communicate and we will get some kind of information. So right, these are the port numbers also very important, right? For example, if you are going to develop on website on your name, HTTP, the port number we have to open, then only, so whatever the website you have developed on your name, if you are going to browse in the particular website, we are going to get the information. Otherwise, we are not able to get the information, right? Generally, the information we are going to develop, we have to check with the domain name service, DNS, and we are going to check with the IP address, and we are going to check with the URL, right? For example, if you want to check some information or some website, maybe it is a domain name service, the port number is 53. So, or we are going to check with some IP address, right? So, what is IP? Here IP is what? Internet protocol. Again, it is classified into two types, IPv4 and IPv6. These are the network layer protocol we are going to study. So, here IPv4 means Internet Protocol version 4, right? IPv4 is Internet Protocol version 4. Right? So why IP address is that much important? For example, you want to browse something, you don't know the domain name service, you don't know the URL. With the help of IP address also, we are going to browse some website, right? For example, the IP address 190.10.10.20, this is the IPv4 address. So here, each and every this number, it consisting of 8 bits, it consisting of 8 bits, and it is also consisting of 8 bit, and it is also consisting of 8 bit. So here 4 into 8, it is going to become 32. So here IPv4 is the 32 bit address length. So IPv4 is what? 32 bit address length. So here 2 power of 32. So if you are going to calculate 2 in terms of 32 times, you are going to get 4 billions of IP addresses you are going to get. So here this is IP address generally if you are going to get. So for example 190.10.10.20. So 4 into 8, 32. So how many IPs is going to provide this IPv4? We are going to calculate 2 power of 32 is equal to 4 billions of IP addresses we are going to get. For example, if you want to assign some IP addresses to the one virtual machine, for that we are going to, how you are going to assign that IP addresses, right? For example, if you are going to design one VPC, that is VPC means virtual private cloud. So it is a VPC. So for example, inside the VPC, again you want to design, one is web server and one is database server. One is what? Web server, and second one is database server. Right? So inside the VPC means what? It is a virtual private cloud. It is a virtual machine. For this virtual machine, if you are going to assign one IP address 190.10.10.20, if you are going to give us a IP address for this VPC, right? While creating the virtual private cloud machine, we are going to assign one IP address. That IP address is, this is the, for example, of IP address, right? So with the help of this IP address, we are going to create one VPC. Inside the VPC, again we are going to create two. One is a web server, one is a database server. Web server, we are going to give access for all the persons. Right? So because it is a database only, we are going to give the permission only limited person. For example, if you are going to take as a some XYZ company, in that generally they are going to maintain two databases. One is a web server and one is a database server. In the web server, it is going to give access for all the persons, and database server only we are going to give as a limited person. Right? So here with the help of some IP address, we are created as a one virtual private cloud. Once you are created as a virtual private cloud, we have to create one internet gateway, that is IZW. So right, for doing something in the cloud also, one internet gateway, internet gate is required. So that internet gate, so here we are going to say what? Internet gateway. That internet gateway, once VPC is created, we have to give the connection between VPC and internet gateway. Once internet gateway is created, then we have to give the connection between VPC and internet gateway, right? So here what I want to do, for example, so here I want to allocate some 256 IP addresses for this virtual machine. Right? So for that what I will do, so I will, for example, it is a web server. So while creating the VPC only, so what I will give as a 190.10.20/24. So this /24, it indicates that prefix of value, prefix of the value, right? So what is the prefix means? So whatever the machine you are going to create, for that machine, we are going to allocate some kind of IP addresses, right? So here it is a 32-bit address. So here we are going to use the formula is 2 power of 32 minus n. So here n is the prefix of the IP address. So if you are going to use 2 power of 32 minus 24, you are going to get 2 power of 8. 2 power of 8 is equal to 256 IP addresses. We are going to assign this particular virtual private cloud machine. Right? Again, so inside that we are given as a two web server, one is web server and one is database server. Simply we are divided into IP address 2. Again the 256 I am going to divide it into 128. Some 128 IP addresses I will give to the web server and 120 IP addresses I am going to give as a database server. For if it is a web server, we are going to say as a it is a public subnet. Right? So it can give as a, see the name we are going to give as a private subnet. Right? So for this public subnet, so while creating the public subnet in the cloud, so here also we are going to assign one IP address. So what is the IP address here? 190.10.10.20. So here, so that public subnet we are going to create inside the VPC. While creating the public subnet, so it is going to ask where you want to create and which machine you want to create. You want to create it in the VPC or you want to use as a default VPC. If you want to create in your VPC, so we have to select, so already we are created with the name of some name we are given for the particular VPC. That name we have to select, inside that only we have to create our public subnet. For that public subnet, again I have to give as a IP address, so how we have to give 190.10.10. So here I am going to give as a 127, right? So here it is going to start means, so it is going to take 0 to 127 means, so it is going to take as a 128, right? So like that we are going to divide it into these internets protocols, like public subnet we are going to assign some 120 IP addresses and private subnet also we are going to assign 120 IP addresses, right? So like that, this much important, so IP address. So IPv4 is Internet Protocol version 4. So it is look like IP address, each and every number it consisting of 8 bits, 8 into 4, 32-bit address length, and if we are going to calculate 2 power of 32, it is going to get us a 4 billions of IP addresses, right? So this is the regarding how HTTP is going to work, right? So next, like that only, HTTP is a client server architecture. Next one is a COAP, Consent Application Protocol. So here it is also going to work as a client and server architecture. Client and server architecture, COAP. So client will send request to the server, server will respond to the client. But so here, so how much we are going to use as a HTTP, that much we cannot use as a COAP, Consent Application Protocol, right? So here also it is going to follow what? Client and server architecture only. But so here we are going to talk about confirmed message and non-confirmed message. So what is confirmed message means? Client will send request to the server, but server will respond to the client with some ID number, right? Client is going to send request from client to server and server is going to respond to the client with some ID number. Then we can say as a, it is confirmed message. For example, non-confirmed message means client will send request to the server, but server will not respond to the client. Client is going to send request with some ID number, client to server, but server is not going to respond. Then we can say as a non-confirmed message, right? Next one is WebSocket. It is a full duplex communication purpose we are going to use, right? So WebSocket, full duplex communication. So for example, how mobile phone is going to work, right? At the same time, the communication is going to happen from client to server. So with the help of some single connection and with the help of some handshake. That is what? WebSocket. The next protocol we are going to talk about message queuing telemetry transport protocol. This message queuing telemetry transport protocol is used for the purpose of publish subscriber model. So how this MQTT is going to work? So here right? So I said, right? So HTTP, what stands for hypertext stands for protocol. So here we are going to use as a client and we are going to use as a server. So client will send a request to the server and server will respond to the client. It is what? HTTP, hypertext transfer protocol. So I said we are going to get some status code, right? So here we are going to sending, suppose for example, with the help of some URL, you are going to browse in the network, right? Some web browser, with the help of some network you are going to browse. So here, so generally the HTTP versions are classified into HTTP 1.1 and we are going to use what? HTTP 1.0. So here, so what is the URL we are going to use as HTTP 1.1 version? So here, with the help of some URL, we are going to browse the data. So this here what? Like client. So here is what? Like server. So right. So server returns the response message, right? What response message it is going to give? So 200, so means it is going to establish the connection successfully. So already I said 200 to 299 means the connection is going to establish successfully, right? The next COAP, just now I said COAP means what? Constrained application protocol. So in the constrained application protocol, it is also client server architecture. It is also going to follow as a HTTP only. But how much we are going to use as a HTTP, this client and server, this COAP, that much we cannot use. So it is also following the same client and server architecture, but we are going to following as how it is, what is the confirmed message and what is the non-confirmed message. So it is going to talk about COAP. It is also here also whatever the commands we are going to use in the HTTP. So like get command, put command, delete, update, whatever the commands we can use, same commands we are going to use in the COAP, constrained application protocols also. So next, for example, non-confirmed message, right? So client is going to send request to the server with some ID number. So what is the ID number here? Some 0xAA51 is the some ID number. We are going to sending, client is going to send a server, but we are not responding in the same way server to client. So that's why we are going to say it is a non-confirmed message. Means client only sending request to the server, but server is not going to respond to the client. But here we are giving some ID number with the some request, right? That is non-confirmed message. Next, confirmed message means, so here see, client is sending request to the server with the help of some command. So what command we are going to use? Get command we are going to use. The confirmation message, some ID we are given, for example 0xAA51. So the same way the server is going to respond to the client with some acknowledgement, some ID number. So that's why this one we can say as a confirmed message in the constrained application protocol, right? This is regarding COAP, right? The next one is message queuing telemetry transport protocol. It is a publish subscriber model and it is a lightweight processor. So here the publisher will publish the messages. So in between subscriber and publisher, there is a one MQTT broker is there. The responsibility will take as a MQTT broker. Whatever the messages is published by publisher, that all the messages will reach to the MQTT broker. That MQTT broker, whatever the messages we are subscribed, so whatever the different types of subscribers are there, that all the subscriber, this MQTT broker will send the messages. It is a MQTT broker. Right? For example, so for example, we are going to take as a publisher. If you are going to take as a, if you are going to use some temperature sensor, if you are going to use, so what temperature sensor will do? The temperature sensor, it will detect some temperature value, right? For example, the temperature value is 28 degrees centigrades. That 28 degrees centigrades, it will reach to the MQTT broker. So that MQTT broker, for example, the subscriber, for example, if you are going to use what? On mobile phone, we are the subscriber. Whatever the temperature value generated from the IOT device, that value will be reached to the where? So here one subscriber is the mobile and here one subscriber user is using some laptop or desktop or whatever it may be, right? So whatever the messages we are going to publish, that published message will come to the broker. From the broker, it will reach to the all the subscriber it is the MQTT process is going to follow. It is a publish subscriber model. Publisher will publish the messages and broker, it is going to act as a third party person or third person we can say between publisher and subscriber. Third person we can say as a MQTT broker. Right? So next, for example, how it is going to work as a MQTT, right? So here publisher one moisture sensor is there, right? So here what is the moisture sensor use? The moisture level sensor, it will detect the how much water level is required for the particular soil, right? So here for example low moisture level, right? So if it is a low moisture level, then it is going to send a low moisture level to the particular subscriber, right? So and subscriber 3, so here water, so automatically, so if you are going to take as some application of agriculture, so if you are going to integrated in some sensors into the some agriculture land, so there we are going to use as a MQTT is a one kind of protocol. This protocol will send some information to the who are the subscriber, right? So IoT means completely it is a without human intervention. The person is somewhere, we have to send the information. For example, when the pump is on, when the pump is off, what is the moisture level, that all the information we have to send to the subscriber. So here this with the help of soil we are going to send, with the help of soil moisture we are going to send this all the kind of information, it is going to reach inside the user interface. Who are the user interface means whatever the subscriber is going to use as a some mobile phone, that all the kind of information we are going to get the subscriber, like what pump, when pump is on, right? So when what is the soil moisture level, all the kind of information we are going to get, like who are the subscribers they are going to use, right? For example, low moisture level. So next, what it has to happen? The pump should on. So right. So these kind of information. If the moisture level is low, then the pump is on. If it is sufficient, the pump is off. Like that, without human intervention only, the particular message queuing telemetry transport protocol is useful. For example, of agriculture application. Right. So this is, for example, you want to switch on one AC, right? So here we are going to use what? One mobile phone. With the help of mobile phone only, we are going to switch on the AC and switch off the AC. Without, we are not inside the room also, we are going to switch off and switch on, right? So here, so already I said IoT means what? Internet of Things. Here all the devices interconnected, right? So for example, so communication means what? Human to human intervention, right? From dog to dog communication is there. So here non-living things, this all the things, right? So non-living things, all are the devices. For example, TV is there, right? AC is there, right? Smoke and whatever the like doorbells, these all are communicating and exchanging the data information. So like that, this IoT. For example, the example of, so best example of IoT is what? Smart home is the best example here. So you want AC, right? You want to open some door, right? You want to smoke detector, right? These are all the things. If you are doorbell, so whatever the things, we are going to operate with some application, right? You want to on particular AC, then we can on from the mobile phone, or this all the things, it is going to happen. For example, in the early morning, so we are whenever we are going to wake up, the clock, right? So if you want to open some door, so it is going to open, right? So and some cup of tea and so water heater, this all the things we are going to open with the help of what? So it is some example we are going to take, right? So here for making of these, so many devices we are going to use. So IoT devices are classified into two types. One is general devices and second one is sensing devices. What general devices? Generally we are going to use different types of devices like AC, right? So some light and TV, so pop, off of these all the things. Sensing devices
Here it is going to include sensors and actuators like temperature sensor, humidity sensor, light sensor. These are the different types of sensors we can use. For example, temperature sensor, it is going to detect as a temperature. Humidity sensor, it is going to detect as a humidity. Next, light sensor, it is going to detect as light. So here we are going to use as a some gateway. So that is the internet gateway. So that internet gateway, again we are connected as a one kind of cloud. So already I said, right? So internet gateway is there. That internet gateway we are going to use as a connections like Wi-Fi, Bluetooth, Zigbee, GPRS. These kind of connections we are going to use for getting the data cloud. On the top of the cloud we are going to install the different types of application. With the help of application, whatever the application we are installed in our mobile phone, that all the information we are going to get. For example, if you are going to give us some simple scenario, so just now I explained how MQTT protocol is going to work, right? So it is a agriculture is the example. So here we are integrated all the sensors. So soil moisture sensor. So here we are going to use as what? Some protocols we are going to use like message queuing telemetry transport protocol, and we are going to use as a HTTP hypertext transfer protocol, and we are going to use as a gate, and we are going to use as a internet, and for the internet we are going to use as a maybe wireless and wire communication based on the wire. Whenever the water level is required, in that case we are going to get, for example, at the what time, what is the date, what is the moisture level, all those things kind of information we are going to get, right? So many applications are there in a IoT